So we will do some graphing, okay? Not a truckload, but we'll do some. And normally we're going to be talking about the relationship between one variable and another. How are they related? Could be a straight line, could be curved, it could look like that, couldn't it? You don't know. But on this case, as volume increases, temperature increases. Fair enough. So could you do any experiments to test that volume and temperature increase?
Yes.
How?
Turn the temperature down.
Yeah, turn the temperature down. In this case, it's for gases. Okay, that's the other thing that's not explicitly written on here, but it is a balloon, volume of a balloon. So how could you test that the volume of a balloon will decrease as the temperature decreases? Can you change the temperature of your balloon?
No, in the area around it.
No, but you can have it in your environment.
I can take kind of hard to heat up. You can put it in a freezer, can't you? Take your balloon, fill it up at room temperature, and put it in a freezer. Freezer's cold, isn't it? Temperature goes down, so what should happen to the balloon?
Shrink.
It should shrink. Yeah, it should shrivel up some. It does. Go home and try it.
I might actually.
Is it because the gas is actually more condensed at that point?
Yeah, the gases slow down. They have less kinetic energy, so they condense a little bit.
Okay.
Or not condense. They get closer together. They don't condense is a special
Don't
term.
take up as much space.
They just don't take up as much volume. Their volume goes down because they have less energy. Kind of like you. When it gets cold, what do? Get inside and huddle up under blankets, right? Got less kinetic energy. Gases are the same way. They slow down. So the volume goes down. They don't need to take up as much space. Okay? We'll talk about gases when we get there. We're going to talk more about them just a sec.
Is there a lot of math that we use?
We're getting ready to talk about that. Just hold on. We have to talk about numbers real quick. Some of this terminology you guys should all know, right? Hopefully.
Yeah.
These are two numbers that are being described here. Let's look at this one over here. These terms describe what place these digits are in, right? 8 is in the, let me change the color. 8 is in the ones place. 1 is in the tens place. 5 is in the hundreds, and 2 is in the thousands place. So this number is 2,518. Okay? These terms describe each one of these digits. Now this number is different. It still has 4 digits, but they're in different places, right? 6 is in the ones, 4 is in the tenths. Note the TH here. That means it's a decimal number. 4 is in the tenths place. Not the tens, but the tenths. 0 is in the hundredths. Hundredths, not hundreds. 7 is in the thousandths. 6.407. Okay? TH means a lot, doesn't it? Okay. Positive and negative numbers. We normally omit the positive sign in front of numbers, don't we? We don't normally show it. If it has a negative sign in it, it means it is less than 0. Positive numbers are greater than 0. As a number gets bigger and negative, it gets further away from 0. Negative 0.01 is smaller than negative 0.1, right? So if we have two numbers, negative 0.01 and negative 0.0001, this one, because it's further to the right, this is now in ten thousandths, 1/10,000th. This is only 1/100th. Okay? This number is bigger than that number. It's closer to 0 than that number is, right? What about 0? Positive or negative?
Neutral.
It's neutral, so Switzerland in numbers, right? It's not positive or negative. One is closer to 0, 10 is bigger than 1, it's further away from 0. Okay? Now, when we do calculations with positive and negative numbers, when we do multiplication and division, 2 positive numbers always give a positive answer. 2 negative numbers always give a positive answer. 1 positive and 1 negative give a negative answer. No matter what the system is. If you have an odd number of negative numbers, your final answer will be negative. Okay? when you multiply and divide. So you have to think about things a little bit and check your signs. You should always check your signs, okay? Now, when you're adding and subtracting, it's a little bit different. Two positive numbers always give a positive. Now, two negative numbers also give a negative. When you have positive and negative, when you add and subtract, it depends upon the magnitude of the two numbers. Okay? So, top example, 3 plus 4 is 7. Negative 3 plus negative 4 is negative 7. Two positives, two negatives, the sign doesn't change. Now, what if we change this down here to 15 plus negative 12?
It'll be positive 3.
Then it's positive 3. Why is it positive? Because the positive number is bigger than the negative number, right? Here, the negative number is bigger than the positive number, basically, is one way to say it. Okay? Therefore, we would have a negative answer. Who brought your calculator today? Everybody have a calculator now?
Scientific calculator too, this class, okay. I need to
Yep.
ask that.
Yep, it has to be able to do scientific notation and logarithms.
I thought.
Okay? I said the other day, like, this one's the one I use. It costs about $12 at Walmart.
Okay.
I have seen some cheaper ones, like, I saw some at Rose's the other day, were like $4. I don't know if they work or not, I just saw them. They do sell some at Dollar Tree that are like $1. I don't like them because I can't see keys. Graphing calculators, of course, do what we need them to do and a whole lot more. Okay, this is like, this one, like if the one that she has is like a Toyota Corolla, does all the basics that you need to do, this is like a Camry, right? Does a little bit more.
It's $10.
It was 10. Where'd you get it for 10?
Walmart, last year.
Okay.
Last year at Walmart, it must have been on sale. Really?
$10 or $11, yeah, wasn't more.
That's a bargain. Should have got 2. I never buy just one calculator, I always buy 2. Because I figure one of them will break.
Scalp one to somebody else.
Actually, I don't buy them anymore. Students leave them. They never come get them.
What's the most expensive calculator you found?
Oh, I've had graphing calculators that students didn't come back and get.
Oh, okay.
Take the final exam and leave it in the classroom, don't ever come back and get it. Like, okay, whatever.
I know the one I got from the bookstore 8 years ago for electrical class was one of the highest.
Yeah.
Oh my God.
Yeah.
It was expensive. Not from the bookstore.
All right.
You gonna teach us how to use this?
They're high.
We will. We'll do even more with it on next Wednesday.
Okay.
Okay, percentages. Who knows how to do percentages? Percentages are really parts out of the whole, right? Times 100. All right, so y'all think you know how to do it?
Yes.
Tell me, what percentage of students in this room are male today? Huh?
One man.
One?
Students, only students. What percentage are
Oh,
male?
wait, 1, 2, 3, 4,
Very good, Margaret.
5, 10, 11, 12, 13, 14, 15, 16, 17, 18,
You gotta know the whole, don't you?
Yes. 120.
There's 20 people here today, so we have one male out of, there's 20 people?
Yes, 20 people.
20, including him?
Oh, 21.
It's 21.
Oh, 21 including him. That changes it.
Wait.
It's a 20, 20 women.
2, 4, 6, 8, 10, 12. There's 21 students. So what is that? 1 divided by 21 times 100.
2.1%.
It's like 100 divided by 21.
So what is it?
2.1%.
It's not 2
No,
point.
it's 4.7.
4 point what?
4.76.
4.76%. Almost 5% of students are male. Almost. Not quite. All right. I'm going to test to see if you really know how to use percentages. Let's assume that this number holds true for all my classes. Okay? let's say I have a total of 72 students. How many of them are males?
How many or what percent? How
So you-
many?
How many of them are males? We're going to assume that the percentage remains the same as it is in this class, right? How many males would I have if I had a total of 72 students?
2 times 4